Hey everyone, CyberCDH here. Hope you're doing really well. Today we're going to take a look at a question that was posed to me on my YouTube channel by Mav. Mav says, "Hi Colin, I'm 22 years working in the IT industry, mainly supporting Windows networks. I'm thinking of changing paths, going into IT security, pen testing and coding. Done some VB a little while ago. Where would you recommend I start with regards to coding? Where would you recommend I start with reverse engineering malware? And is there a basic course or certificate that I should be working towards?" Really, really great questions. And we're going to take a look at how to level up your game. Okay, so we're going to take a look first at what to expect in a couple of different roles here. If you're a malware analyst and also if you're a pen tester, what can you expect to be doing on a day-to-day basis? Well, from a malware analysis point of view, you'll be the person that's dealing with the escalations as part of a blue team incident response. So they're sometimes called a CERT team. Really on the front line of incident response here to reverse engineer malware really, really quickly to determine the key indicators of compromise, so you can go looking for or hunting in your environment other potential infections, but more so you can contain, eradicate and recover super quickly based on the intelligence that you'll be able to provide the incident response team. So really super cool role dealing with high profile escalations, and you'll be focused on looking at attack vectors. So how did the bad guys break in? Was it a phishing email? Was it an exploit? Reverse engineering that particular method, getting down and dirty with the code, working out whether code is actually malicious or not. A lot of stuff you'll deal with may well be false positive, but you need to get to grips with what's malicious, what's not, and also how to extract the key indicators of compromise so you can go and best protect your environment. As a pen tester, what can you expect? Well, firstly, you'll be doing web application security testing. So you'll take a web app, you'll attack it within a predefined scope and work out whether there's any bugs there that will be significant in terms of your business processes. Can you compromise, escalate your privileges? Can you compromise user data? Is this safe? Is this application safe to be put into the wild? Maybe it's going online, front face into the internet. Is it going to be an application that's going to be heavily exploited and targeted? Well, you're going to test that and find out before hopefully the bad guys do. You might well get involved in hardware testing as well. So if you could be pulling apart routers, switches, IoT devices, all that kind of good fun stuff. Even if you're in the automobile game, you could be ripping apart the hardware to do with cars and tracking, all the rest of it. Absolutely fascinating world here of hardware security. Also, physical security pen testing as well is such a thing, right? You might be tasked with trying to physically break into an environment. Maybe it's a secure location, a data center, or somewhere that stores super confidential information. How secure are the physical controls within the building? Also as well, there's such a concept as red teaming. So red teaming is all about putting all of those skills together, attacking an organization, maybe your own or an organization that you're working for, in order to understand where the weak points are, where they need to focus and build their strategy. You can definitely expect to be doing lots of scoping, lots of documentation, report writing. So if you've got the skills to translate super complex information into non-technical information for audiences, then you will definitely be able to start succeeding in this particular area. Also, you can expect to be doing lots of researching, keeping up to date with the latest tools, tactics and procedures of bad guys and what is going on in the wild in the cyber threat landscape, so you can keep your game in tip-top condition. Okay, let's talk about coding now. So in each of those roles, if you're a malware analyst, if you're a pen tester, in the blue team, red team, purple team, whatever, what are the kind of responsibilities or the desirables for knowing how to read and write code? Well, I'm going to give you my take on that right now. So let's get into it here. So first off, from a malware point of view, you're going to be faced with so many different types of code in so many different types of languages. You can't really legislate for what you're going to be attacked with. Bad guys use Python, they use JavaScript, they use VBScript, they use VBA, they use C, they use .NET, they use anything that's at their disposal that's going to potentially run in your environment. And so you need to be familiar with how how code executes in the particular environment that's being attacked. So if it's a web application, it might well be that you're reverse engineering an exploit that's fired against that particular application. It might, if you're dealing with an endpoint, so let's say a Windows machine, it could be an executable that's written in C. You need to get down and dirty with some x86 disassembly. And so here is a prime example, right? This is a piece of malicious, it's a HTML file, but all the contents within it are JavaScript. So this is what malicious JavaScript looks like. And this is a prime example of something that you're going to open up as a malware analyst and think, shit, what do I do with this information? How do I extract the key indicators of compromise from this? And you've got to break it down, and you've really got to kind of see the wood from the trees. So definitely being able to interpret this kind of information is definitely key. Let's go on. So also JavaScript I mentioned as well is not just for web side of things. JavaScript can execute on a Windows host as well, and so you need to understand the concepts of how JavaScript can interface with the operating system. And also, bad guys don't make it easy. Okay, you're going to be faced with code that is really difficult to read and really difficult to understand, and you've got to kind of pick it apart. You might be dealing with files of thousands of lines of code, and you've got to find a way of getting right to the heart of it to understand which bits are the malicious bits, which bit is just noise that's there designed to put you off and spin your cycles, so you're reverse engineering functions that don't do anything. Also, we're going to talk today a little bit about cryptography, and here's a little snippet here as well. So bad guys will often use encoding and encryption techniques to hide all of their malicious source code or the malicious indicators. It's not always going to be in plain text when you open the file, and you're not always going to see the C2 information or the registry location or the file location or what have you. You're going to have to do some work to pick apart the code and decrypt it or decode it. And in this particular example, here's an implementation in JavaScript of a popular stream cipher called RC4, and we'll talk a little bit more about stream ciphers and the importance of understanding cryptography in just a few minutes as well. What else? Well, as a pen tester and also as a malware analyst, you're going to be faced with either writing or reading malicious web infrastructure. In this particular case, here's a snippet of a phishing kit source code. So as a malware analyst, you'll definitely be looking at phishing code and working out like where the credentials are going to be posted to, potentially who is the bad guy, what's the infrastructure behind it, and being able to interpret HTML, JavaScript, and also PHP is really key. PHP is a really good language to learn because it's quite high level, but in terms of the concepts and the way that it's actually written, it's very, very similar to C, which is kind of like the fundamental language that really, if you wanted to learn any, you would start there, and it would give you a good grounding in pretty much everything. In this case, you'll be able to pick apart like what's noise, what's good, and what's bad. And here you can actually see up here, there's a little backdoor in this code that will run a system command of any get parameter that's called user agent on this particular web server. So it's quite interesting what you can find when you do start picking apart code. Pen testers, you'll probably be having to write this kind of stuff. Malware analysts, you'll definitely be able to have to read this kind of stuff, interpret it, and work out, are there any kind of nuances here, any backdoors, any kind of hidden pieces of information. Also, I'd recommend looking at the language Go, especially if you're a pen tester. So many tools are being written in Go for recon, for pre-exploit, post-exploitation, what have you, cross-platform. It's super simple to start writing, especially if you've got a bit of a background in other coding languages. Many people have probably had experience with Python, and if you've never written anything in Go, you'll probably feel like it's a little bit different, but the learning curve is not as steep as learning Python for the first time. So if you've already got a coding background, you'll find Go really, really intuitive. Here's a snippet of code that I wrote recently. I'm definitely not a developer by any stretch of the imagination, and I can get to grips with Go just by kind of pulling from repos that are already on GitHub. So if you want to write your own tools, if you want to write your own exploits, Go is a really good tool in order to get yourself going. Also, especially for pen testers, you should get to grips with Bash and Bash scripting. So not necessarily a language per se, but more so just stitching the outputs of tools together. So the output maybe from one tool, you would want to feed it into the input of another tool, and especially I find this especially useful for recon. So if I'm looking at an environment, if I want to enumerate all the subdomains and find out which ones are live and go looking for all of the APIs that might still be available or live, etc., and parameters to do with all of these subdomains, I want to kind of automate or semi-automate as much of that as possible. And so I write myself little bash scripts or functions. As you can see, here's a snippet from my bash profile. And so at the top here, the recent F5 vulnerability, I wrote a super quick function that can take an IP address as an input, and it will just quickly check to see whether or not the IP is vulnerable to this particular exploit. Also a little bit meatier, my recon methodology. So I stitch a few tools together: asset finder, subfinder, find domain Linux. I'll do some subdomain takeover checks. I'll feed it into Aquatone and then do some tidying up as well. And so get to grips with bash functions, especially just makes your life easier, makes it you have repeatable processes which you can just fire at environments, and then it means you can focus on the output rather than the actual usage of tooling. So get to grips with bash is definitely a key one. Also on the malware side of things, when I talk about bash or shell scripting, this is an example of some malicious shellcode, malicious shell script, which is in this particular case is a coin miner that's designed to run in a Linux environment. And you need to get to grips with really ugly code like this. You'll be faced with working out, well, these are all genuine commands that will run in a Linux environment, but what's important here? How is it persisting on the disk? How is it maintaining its persistence in order to make connections to the malicious C2? What is the malicious C2 and how does it connect? Are there any special parameters that I need to replicate in order to analyze that particular infrastructure as well? So that kind of code is definitely stuff that you should get to grips with. Linux, super important, especially a lot of servers obviously use Linux to run their services on, perimeter servers especially, and the ones that get popped for coin mining generally Linux, and so you definitely want to get used to those kind of commands and also what malicious Linux commands look like, such as this. Okay, zooming out a little bit, let's go to the kind of Windows environment. .NET is another kind of area which you should familiarize yourself with. This is a piece of malware that's written in .NET, in this particular case VB.NET, and you can use decompilers to get close to the source code or get the actual source code, but in a .NET world. But it doesn't mean it's going to be easy. The bad guys know that you can get their source code by decompiling it in memory. However, they use techniques here to either pack their code or obfuscate it, encrypt it, encode it, etc. So you've still got work to do here, and the key is not to be put off. The same concept of working out how this code is going to execute on the machine, breakpoints at certain points within the code to help you work out when you're in packed and unpacked territory to dump out the original source code and get closer to the IOCs. It's all about spending time in the debugger and really just kind of not giving up and persisting with the code, and you will definitely make it through. Okay, what else? VBScript. I talked a little bit about VB then. Or VBScript, Visual Basic for applications as well, definitely features very heavily in your day-to-day life as a malware analyst. This kind of stuff are all ActiveX Windows commands which will run in a Windows environment and interface with the operating system. It's just all about getting to grips with code that doesn't look very pretty, but how do you kind of tidy it up, cut the noise out, and determine what are the most pertinent indicators in order to, as I said before, contain a threat, eradicate and recover. So what blocks do you need to put in place straight away? Well, we see in this example as an IP address. Well, you would be blocking that IP address on your in your environment straight away if you saw this code, before you even go and further analyze it, just because that's what you see on the screen. You got a registry key. It might be that is something to do with the persistence of the malware, therefore gives you something to go hunting for. I say about VBA, so just a different kind of flavor of Visual Basic, if you like, within the Windows estate especially. So malicious macros within documents, within Excel files, within PowerPoint are definitely going to be your bread and butter as a malware analyst, and you'll be seeing shit like this all the time, and you think to yourself, how on earth are you going to analyze this? How do you run it? How do you get to the stuff that's meaningful? What are the indicators of compromise? Again, it's all about stepping through the code, understanding what's noise and what's not, and having an understanding of how VB operates on executes rather on the operating system is going to be really, really beneficial. What else? Getting right into the weeds of it here. So there's going to be malware that's not written in a high level language. It doesn't use VB, it doesn't use JavaScript, etc. And it's going to be written in C. It's going to be compiled, a compiled binary that you need to disassemble if you really want to understand exactly how it operates. What is it looking for in the operating system? How is it compromising a machine? How is it maintaining persistence? You can definitely run malware. You can analyze malware from a behavioral point of view, but a lot of times you want to back your behavioral analysis up with some static analysis as well. And static analysis means getting into a debugger like this or a disassembler, pulling apart the assembly and looking at the API calls. You can see here, there's one highlighted, create tool held 32 snapshot is the start of an API routine to look at all of the running processes on a machine. This particular piece of malware was used in the great Bangladesh bank heist from a few years ago, where nearly $1 billion was stolen from a Bangladesh bank and wired into various accounts all around the world. And it did that by looking for particular processes running on the endpoint, and it wouldn't further infect the machine if it didn't have these processes. It was looking for a very specific environment, and if it had a particular service running, it would inject code into a DLL and overwrite and patch some of those checks that were made in memory. An absolutely fascinating piece of malware. But in order to understand that, you need to get down and dirty with a bit of x86 and some API calls and understand how they operate on the system. As well, something to note within assembly, really good starter for 10. Firstly, you want to work out what a function epilogue and prologue are, so you can work out where functions end and start. But also as well, conditional logic is really, really key. In most languages, you'll probably come across if blocks or if conditions, right? If, else, then, whatever. Same as in assembly, you can see there's a lot of JE, JNE, there's a JMP, etc. And those are all jump statements, and some of them are conditional. You can see the top one here. Prime example, there's an API call to get system default lang ID. It's one of my favorite pieces of malware, this. And there's a comparison. So it's going to look at the system default language, compare it to a particular number, and then there's a decision. You can see there's a branch that's made, right? So the program will flow in one direction or another based on that call. You can patch the response, or you can follow the code and analyze it. But the key is recognizing when these conditions are going to be met. Again, all down and dirty with a bit of x86. You've got to love it. Also, on the subject of x86, as a pen tester, you're probably at some stage going to be coming up against having to inject your own shellcode into a running process. And when you've got some shellcode, you need to work out the x86 yourself. And so you've got to craft a payload. In this particular example, you'll be crafting a reverse shell to be injected into a process, which will talk back to your interpreter listener. Fascinating stuff. Probably one of the sexiest parts of pen testing or red teaming is crafting your own payload and popping that in an environment to get your shell, get your root, run your who am I's, etc. All really good fun. So to kind of sum up on this side then, as a malware analyst, you definitely want to be able to read most of those languages, be able to interpret what is going on in the flow of the code. Don't necessarily need to write in any of those languages, but definitely have a high proficiency of being able to read. In pen testing, you probably want both, especially in JavaScript, in Python, in Go, a bit of x86, not necessarily having to write a full executable, but being able to write a payload is definitely going to be key for you. So there's some tips on coding. Okay, let's take a look at some resources now. So some resources for pen testing. My favorite hacking newsletter is this one from Pentester.land. Pentesterland, the website is full of amazing resources, but the newsletter, I just love it because it gets emailed to me every week. It gets pushed out, and I absolutely love the content. favorite tools, there's favorite write-ups, there's videos, there's blogs that get referenced, there's new techniques. It's always so current. Whoever puts these together, they're so well informed as to what's going on in the industry. So definitely sign up to this newsletter and you'll be on top of the latest tools, tactics and procedures of what is going on. There's a great podcast, there's resources on the website here, tips, tutorials, and also what I find really cool is a list of bug bounty write-ups. So you can see actually as a pen tester, day to day you'll be attacking organizations maybe that you work for or consult with, but actually you can take your skills into the bug bounty arena and go and earn yourself some real cash with the likes of PayPal, with Facebook, with Yahoo, etc. Loads of companies that run bug bounty programs. And so there's some cool write-ups here as to people who have been successful there, and so you should definitely research what tools and techniques that they're using as well. Also as well, if you want to get down and dirty and do some practicing, there's so many labs online, Hack the Box and all those kind of real kind of CTF platforms as well that you can get dirty with if you like. One of the labs I really like, or a collection of labs that I really like, are from Portswigger, who obviously wrote Burp Suite, which is the fundamental tool of web app security pen testing. But they've got some great labs as well. So definitely, and they're all free. So sign up for these so you can do some authentication labs, server-side template injection labs, cross-site scripting, SQL injection, etc. And they're really, really good practice grounds. And there's great kind of tutorial method. You get the solutions, and it kind of walks you through and handholds you through some of the really complicated exploit scenarios, or certainly stuff that I find really baffling anyway, at least. So that's a really good resource as well. And as well, a book I'd recommend, Red Team Field Manual, is full of, and look at the price of it, less than a $5, full of amazing commands that you would use pre and post exploitation, reconnaissance, etc. Just a really good reference guide if you're stuck, you're in the field, you're in the middle of a campaign, and you can't get your reverse shell working for whatever reason. Maybe something's being blocked. Well, this has probably got the solution for you. There's some real handy tips in here from proper red teamers who've lived and breathed it over the years. From the malware side, this is probably the Bible, right? So Practical Malware Analysis is certainly a book which really inspired me. A little bit pricey, but you can get it for just under 20 quid. It does come up in the humble bundles from time to time as well, so look out for those. But really the kind of de facto standard malware analysis textbook. And there's others that have kind of been that have built on this in over the last few years, and this was written a good few years ago now. All of the key fundamentals are in here. The tools, the labs are all still really relevant. So definitely check this particular resource out. Also as well, obviously there's a lot of YouTubers out there, myself included, but you've got Hasherazade, you've got Malware Analysis for Hedgehogs, you've got OA Labs, you've got Live Overflow. There's so many different YouTube channels out there that are dedicated to technical analysis, whether malware analysis, whether it's pen testing, whether it's CTFs, whether it's bug bounty, look at NahamSec, etc. There's so many resources out there, so definitely check out YouTube. I would go so far as to say that YouTube is probably my first/second favorite search engine. The first or the other one would be GitHub, and Google would be a close third. So definitely check out YouTube for this kind of stuff, because there's so much cool material out there. Let's get into the subject of cryptography now. And I mentioned this as a kind of like a special little section, if you like, in what I wanted to discuss here. Crypto, as we saw before, I showed you an example of a little bit of malicious JavaScript which uses RC4. You'll come across crypto a lot, especially in malware analysis. And from a crypto perspective, bad guys will either encode their data or they'll encrypt their data, and they won't make it easy for you to extract the key indicators of compromise. So the IP addresses or the URLs that they're communicating with, or the DLL names that they're going to be calling, or the API calls they're going to be calling from their DLLs, what have you. They're going to make it tricky, and they know it's tricky for a malware analyst to kind of reverse engineer lots of code. And so whatever barriers they'll throw in your way, they will do. And obviously they've got to try and evade security controls as well, and using crypto is a really good method around that. So what I would definitely suggest, as a pen tester or as a malware analyst, familiarize yourself with the core concepts of cryptography. And what I mean by that, there's kind of three key areas that you would kind of put into buckets of crypto. So there's secret key crypto, so the symmetric ciphers, so that where you've got both me and you have a password and we've already shared that, and we can encrypt our data symmetrically. So I encrypt data and you use the same key to decrypt it. And there are many kind of symmetric ciphers that you've probably heard of and maybe familiar with, the likes of DES, which is super old, AES, which is a stream cipher, and also, AES, which is a block cipher, and stream ciphers like RC4, which we've already kind of taken a look at with the JavaScript example as well. So those kind of stuff, you definitely want to familiarize yourselves with what is a block cipher, what is a stream cipher, and what is secret key crypto. Also as well, public key crypto, which is used in the web, the kind of TCP handshake, the SSL side of things. You need to understand that as a fundamental, RSA being the kind of de facto standard for public key crypto, and as well hash functions. So MD5s, the SHA-256s of the world, etc. What is a hash function, and why is that important, and how, what are the potential weaknesses for some of the older hash functions as well. A really good resource, a course that I took a good few years ago now, was this one from Courseware, taught by Professor Jonathan Katz. I will admit this course was heavy going for me, especially. I took it twice because the first time round I kind of bluffed my way through it. The second time I took a lot more from it. There's a lot of coding concepts in here, so you'll be writing code to attack weak crypto environments. So you might be like writing a padding oracle attack against a particular key, etc. Super fascinating course, and if I'm honest, I don't remember everything, but I felt like I came out of the course understanding the key kind of core concepts of crypto enough for me to recognize what crypto is being used in particular environments. If I look at a piece of JavaScript, I see some weird code and I can see a key floating around and I can plug it together and determine what is being used, and that might help me reverse engineer it. So this was a course that really benefited me, and I definitely should check it out. Also, an amazing online free resource is this overview from GaryKessler.net. Highly recommend taking a scan through this. It's probably one of those websites that you would bookmark and you would come back to as and when you kind of want to dip in and out of different subjects. But it breaks it down into those sections I talked about: secret key crypto, public key, hash functions, the significance of key lengths, PGP, all the rest of it. An amazing resource which Gary has put together. So I definitely recommend you checking that out. Finally, one of the questions which was kind of raised here was from Math, was around certificates, and I just wanted to kind of mention to you or talk to you about my opinion around certificates and their importance within the industry. I think certificates are super useful if you want to solidify the knowledge that you've already gone away and learned and developed yourself. Because there's so many open source or next to nearly free kind of resources online where you can really skill up, level up your game. YouTube, the Gary Kesslers, whatever it may be. If you can demonstrate that, especially at interview, all of the kind of learning and your skills and capabilities, and articulate that in a way that's understandable and relatable to that particular business, you'll absolutely stand a real good chance of getting into the industry. No problems whatsoever if you don't have the cert background, the certificates to back you up. In the malware space, the kind of de facto certification which a lot of people benchmark the industry by is a SANS cert. So SANS Forensic 610, which is the GREM course, so the GIAC Reverse Engineering Malware Certificate. I took this course a couple of years ago now. Fantastic course, very expensive. And did I need it to get my first job in the malware space? No, I didn't. What I needed to do was demonstrate all of the skills and capabilities that I had, and that course, when it was sponsored for me, really kind of solidified that knowledge. It definitely gave me some new skills and capabilities, but it wasn't a prerequisite. So don't feel like you have to go and spend thousands of dollars on a certification in order to get a job in cybersecurity or in malware analysis. Your skills and capabilities that you've already learned in your home environment should definitely be enough. That's my opinion. Hopefully you found something beneficial from today's session. I really look forward to seeing your questions, your comments, and joining the conversation. You can follow me on Twitter at CyberCDH, and I'm really looking forward to pushing out some more content. So check this out. Thanks, guys.